आज पूरी दुनिया कहाँ से चल रही? इनका दाता चला रहे हैं पूरी धरती को। तो इनका दाता लिखो DATA, अब इनसे अंग्रेजों से बुलवाओ डेटा। तो इनका राम के बिना कंप्यूटर नहीं चलेगा और डेटा के बिना ये संसार नहीं अब चलेगा। तुम्हारा कोई भी धंधा हो भैया, डेटा से चल रहा है। डेटा सेलिंग चल रही है अंडरग्राउंड इस पृथ्वी पर। अब दुनिया के पास डेटा है तो स्ट्रेंथ है। तुम इनका देखिए, दाता भी हैं हमारे, राम भी।
Hello everyone. Today we're going to discuss about databases. So this is the early concept of database. Before the database were discovered, how the data was managed and stored. So file-based approach, history of databases before database discovered. File-based approach were an early attempt to computerize the manual filling systems. This is not the as much early as the data entries were made in pen and paper, but this is after the development of the computers. This is after we developed the Word files. So we can store and create one Word file and then stores multiple files. But this was hard to store if you have a large number of data or large number of files. There were certain limitations of the file system like separation and isolation, duplication of data, data dependencies. Data dependencies means that change to an existing structures are difficult to make. For suppose if you have created a file and then you realize you have made some of the mistakes in the file, then if that file is connected with three more files, then first you have to correct the information in first file, then the other connected three are also have to be opened manually and then corrected. To become more effective, a new approach was required that emerged the databases and the database management systems. For understanding deeper what actually is the database, we will read out the definition. The database is the single, possibly large repository of data. The term repository means a virtual area where things can be stored that can be used simultaneously by many departments and users. Instead of disconnected files with redundant data, all data items are integrated with a minimum amount of duplication. The database holds not only the organization's operational data, but also a description of this data. For this reason, a database is also defined as a self-describing collection of integrated records. A database not only stores the data, but it defines the data. It has the definition that what the data is being stored. As we will move forward in the video, you will understand this with examples. So the correct definition of a database is also defined as a self-describing collection of integrated records. Then the database management system, DBMS, a software that enables user to define, create, maintain, and control access to the database. I don't think so there is any need of explaining it more. The definition is very clear now. It allows user to define the database, usually through a data definition language, DDL. The DDL allows user to specify the data types and structures and the constraints on the data to be stored in the database. See, as you study database, there are certain types of database commands like DDL, DML, TCL, and one or two more we will study in the video. So don't worry if you are not getting it right now. I will shortly clear the concept of these. So it allows user to update, delete, and retrieve data from the database, usually through a data manipulation language. Having a central repository for all the data definitions and descriptions allows DML to facilitate the data is called as a query language. Now, what is a database? The definition of database is always stored in its part called as DDL. DDL is a data definition language which allows user to specify what type of data is being stored like int, string or boolean, and the constraints means if you are storing a integer data type, then how long should the integer be of, what size of the integer should be stored, either 15, 20, 50, 100, etc. Then a DML, data manipulation language, usually allows user to update, insert, delete, manipulate the data Firstly, the data is defined, the data is stored, then you can manipulate the data. So these are the two main components of the database management system. A software where these two commands are created or performed is known as a query language. Okay, where the user has fixed set of queries to build a database is known as structured query language, SQL, or sometimes it is pronounced as SQL. Then these are some of the advantages and disadvantages of DBMS. You can read it out. I will upload the slide. Then introduction to SQL, SQL. Ideally, a database application should allow a user to create a database and relation structures, perform the basic data management tasks such as insertion, modification, and deletion, perform both simple and complex queries. This is the requirement of what a database program should have. If you are using a database language, what the language should have? The language should have a simple operations like insertion, modification, and deletion, and it can perform or execute simple and complex queries in it. SQL is an example of transform oriented language, or a language designed to use relations to transform inputs into required outputs. A transform oriented language means that you are supposed to give an input and then the language itself transforms, then give back the output. So the SQL, what the SQL does, SQL, you input it some queries, the SQL will upload it to API, then the API will, through the APIs, it will go into the databases, then make the changes in the database, then come back to the API, then return the output to the user or to you. As a language, SQL has two major components, DDL, DML, we discussed earlier. Coming here is another concept of literals. Literals are the constants that are used in SQL statements. SQL statements, there are different forms of literals for every data types used. For simplicity, we can say some are enclosed in single quotes and some are not enclosed in quotes. All the numeric or non-numeric data values must be enclosed in single quotes. All the numeric data values must not be enclosed in quotes. So what the literals are? Literals are the constant values in SQL statements. For example, this is a simple query input query example, which is insert into property for rent, property number, street, city, postcode, types, rooms, etc. Then here are the values of this, like property number, we have PA14, which is enclosed in quotes, single quotes. So what these quotes means, these quotes have are called as literals. The values in these quotes are constants or literals, and all the non-numeric values means alphabets, strings, characters are always stored in single quotes, and the numeric values does not have to be stored in the quotes. Then there are SQL data types. uh, uh, every programming language have same data types almost, integer, varchar, and char. Character and var character has the some of the differences. Where character is the variable form of characters. First, suppose character and where character has a defined size. If you assign the size 200 to a character and assign a size 200 to a where character, so the ideal thing to use is where character. Why? If you given 200 size and you are storing a string of names, and my name is Mohit and it has 5 characters. If I am using character char, so for my 5 character name, if I am using char 200, the 200 of the memory will be lost. How? That 5 characters will be stored Mohit name, but the other will be dropped. 195 characters are waste. But the varchar is starting with, if my name has 5 characters, it will store 5 characters. It will occupy 5 characters space, not more than that. So it is ideal to use varchar rather than char. Then there is text for large text data, float or double for decimal values, date and date time, boolean for true or false values, and there is blob, binary large object, and enum. Enum is something like a MCQ. You are given options. So, for suppose you have seen somewhere the requirement of gender, male, female, other. So this is a enum. Select one of the value from the given values. Okay. Then there are SQL command types: DDL, DML, DQL, DCL, TCL. These were the types which are other than DDL and DML. DDL we have discussed, data definition language. DML we have discussed, data manipulation language. Now DQL and DRL means data query language, which is select. The select keyword is basically used to retrieve data from a table. In the examples, when we will talk about the example, you will see we we are creating a table. We will first create a database, then we will create a table, then we will insert the data, then we have to retrieve the data from the table. So for the retrieving, we will use select keyword data, which is in the type of DQL. Now DCL is to grant or revoke some access, some permissions to open or not. TCL, this is a transaction language, which means uh, either the thing will happen or not. For suppose if we do any bank transaction or something, either the transaction will happen or either the transaction will roll back. The amount will be transferred or the amount will come back in your account. Okay, now these are some of the these are some of the keywords: select, where, between, and sorry, then having versus where, alter table. Alter table means to make alteration in the tables. Once you have created a table, you have saved the data, but now you have to modify it. Now you have to alter the data or the table. So you can add column, modify data type, change column name, drop column, rename table, and make more things. Now let us move towards our some code examples on our SQL workbench. First of all, for coding this, we have to create a database. Wait, let me maximize its size. Okay, create database and e-commerce. Okay. Now, SQL is not a case-sensitive language, but it is said to be considered as ideal to use uppercase letters for SQL queries or keywords and the lowercase letters for assigning some name or values. Now, for here we have created a database named e-commerce. Okay, and now we have to, for using the database, we will write use and the name, use e-commerce. You can see here. Wait, first I will execute this and then refresh it. You will see here a database has created which is named as e-commerce, and we are using currently the database e-commerce. Now you can create a table, create table customers. Okay. Now here I can write ID int primary key, set it as primary key, and then auto increment. Okay, this is the constraint. So one of the concept we didn't discuss, I forgot to discuss, was of primary key and foreign key. Now I hope you are well aware of the primary key, or even if you are not, the primary key is simply a unique key which which every row will have. A primary key cannot be null, cannot be zero, and the primary key cannot be duplicate. This is a unique key. For suppose if your ID number is 1 and it cannot be repeated, the other person will cannot have the ID number same as you have. Okay, then the name column, name can be varchar. Yeah, I told you why to use varchar is better than char, and we will give some constraint of a name can be of 100 characters, and it should not be not null. Okay. One thing I forgot was placing. Wait, the semicolon. Now, after name, what we else can store is email. This also varchar. Email address must fit in 100 size and it can be not null. Okay. Then we can have age int. Mm, Here on email, we can have another constraint which is unique, because everyone has a unique email address. Email address cannot be same, but we cannot keep the email address as primary key. Check age is greater than equals to 18, so he can order. Okay, this is the first table we have created, and we can run this. And if we refresh this, is our table created or not? Let us see. We can check it out by using select command. Select customers. Select static customers. We can select it here and run it as okay. We got the ID, we got the name, we got the email and the age, right? We just now in the order table we can have order ID. Wait, there should be no gap. Int, set it as primary key and auto increment. The other we can keep as order date. Wait, order date. Then we can add amount column, which should have int data type, not null, constraint. Then we can have customer ID, which also can be should have not null. And one thing else is int. and it should have a foreign key, which is customer ID. We are keeping this as foreign key. Now, what is the foreign key? A key which the other table can have. Now, here what you will do is give a reference to the first column, first table's primary key. Reference and then table name, customers, and then the ID. Did I made any spelling mistake? References. Okay. This is how it is created. Now here you will refresh all this, and if you want to see the ER diagram of this, you can go to reverse engineer. You can create a ER diagram, select the table, then continue, then execute, then continue, close. Here are the two tables, customer and order table, and here is the ER diagram. Closing all this, don't save. Okay, so this is how a primary key and a foreign key is being connected. Now what else you can do is select from orders, and if I run this, here my order table is also created. Now some DML commands, data manipulation language commands, where we can insert or something. We are going to insert values to our tables. Firstly, I'm gonna delete this from here and also delete this from here. Okay, insert into customers and name, email, and age. And here you can write values. Wait. Values. You can enter mm, Mohit name, then email can be mohit@gmail.com. Then what is age? Age we can write 21, and then here the other name can be Ali, and email can be ali@gmail.com. Then Ali can be of 105 years. Okay. I guess doing this will be all right. And now if we have to retrieve the data of the customers, we can select customers. Sorry, I forgot again. Select static from customers. And now we can execute this line from here. It is showing null. That means our values are not entered. Now, where is the, if it is, does this command has run? Let us check. Okay. The mistake was of refreshing. Here, after refreshing, Mohit and Ali and both emails and both ages are present. Here, this is how you first define a database or define a table, DDN, and then you manipulate the table, which is DML. After that, you can somehow insert values, insert into orders table. What we can insert is order date, amount, and customer's ID. Okay. Now you have to write values. Two zero two six 03 01. And then you can what we have to add amount 3000 and customer ID we can write 76. Then copy this all. Control C, Control V. We can manipulate this data as 50 and keep this 60,000. The date can be kept same. Okay. Now we can again check select static from orders and run this. Again, I didn't refresh this. I don't know why the values haven't been inserted yet, but we will soon update the data. If we delete this and remove this also, we can learn another command of update customers and then set age equals to 22 where id equals to 1. So there was a spelling error. Customers, now we can just simply first execute this, then we can execute this. And now the age has been updated from 21 to 22. Now we can use some other select commands. We can use select static from customers, where age is greater than 20. And now if you execute this command, I hope I have written some correct. See, now what I have done is I have written the ages where the age is greater than 20, sorry, less than 20. What am I saying? The age is greater than 20, so all the entries will be displayed. Okay. Then one other interesting thing you can download, or you can not download, you can do is you can write select static from customers where name like, this is a like keyword, an apostrophe, m, percentage sign, modulus operator. Wait, right now if you execute this, this will give you the name where only m exists, right? So this was a short introduction of the SQL, like how you can write queries and other things. The next video will contain more informations about it, about the databases, about ER diagrams and other things.